engineer from RQD42 who build a production grade AI system that scale in the real world. So he's going to present today's session about adaptive RAG, a system that learns from the feedbacks and delivers smarter and more accurate response over time. So let's welcome Pratik for his special.
Hello everyone. So myself Pratik. I work at QED42 as a GenAI engineer, and today I'm going to present you one of my experiments. So this is basically an adaptive RAG. So enhancing generation through query clustering and reinforcement learning. So let's see what today's agenda is. So today we will first see today the presentation will be divided into four phases. First, we will just go through prerequisites for this presentation. Second, what was the need for adaptive RAG? Third, was my solution that I built for making RAG more adaptive. And fourth is the challenges and future scope which can be discussed. I think everyone knows what RAG is, right? Like RAG basically stands for retrieval augmented generation. For those who don't know, I will just explain it in brief. So basically, RAG means basically you are providing your model and external knowledge, and I will explain it through this image. So consider you have a knowledge in a PDF form basically. Then we will load a PDF. Then we will convert into a different chunks, and then we will convert into embeddings. Now, why embeddings? Because machine do not understand text language. It only understands maths language. So once we convert into embeddings, we will store into a vector database. So vector database is basically a database where all the embeddings of the PDF will get stored. Now coming this is one phase which is called as indexing, and on second phase, whenever user asks a query, that query will also get converted into embeddings, because same, the machine do not understand text language, it only understand maths. So once it get converted into embedding, we will do a similarity search between the vector database and the query, and the query just returns all the top k search results which we get from the vector database to the model, and then model generates an output and provides us a response which we see today in our RAG application. So this is just a quick recap of what RAG is. Moving on, reinforcement learning. So this is one of the main topic which I am going to cover today. Reinforcement learning is nothing but a trial and error. So consider an agent. So how, if you leave an agent in an environment, how will it learn? So it will learn by trial and error, continuous trial and error. So it will try something, it will get reward. It will try something, it will get a penalty or something. So that's how a agent learns over time. So reinforcement learning is nothing but an agent learning through a feedback. So you must have seen like that ChatGPT sometimes ask you which response do you prefer. So it is actually using a reinforcement learning only behind it. So that's it for reinforcement learning. Next is deep Q network. So basically in reinforcement learning, we store all the actions and states in a queue table, where Q stands for quality. So in quality table, we all store state and action of a reinforcement learning model, is quite uh, which is quite accurate for a smaller scale model. But when you consider a real life example, there are like n number of actions and n number of states which we cannot manage through just a queue table. So in that case, we just replace the queue table by a neural network which learns. So neural network is basically, you can consider it as a mini brain. So it has an input layer, hidden layer, and output layer. Input layer takes data, hidden layer just do pattern recognition, understand what patterns are inside actually the input data, and provides us the output. So we are just combining queue table and neural network into a single network which is called as DQN, which is deep queue network. So we will be using this in my adaptive RAG. Now problems faced. So basically, why do we need adaptive RAG? So first is small models. So if has anyone tried local models, running local models through Ollama? And must have seen that these models, the small models, do not understand users preference or do not understand user query. I will show you an example by running one. So I am using a small model from Google's Gemma model, which is JEMA 3 billion parameter, which is one of the smallest model. It comes under 1 GB basically, and I am running it locally on my terminal. So I will ask him a very simple question. As you can see, I only asked what is Drupal. Like if you ask this question to a chat GPT or anything, it will answer you in a very concise, proper way that what Drupal is exactly. But as you can see, small model do not understand this. It always give a big response which makes no sense as a user or to the end user. So as you can see, it's still going. It's so this is one problem which we face with small model, the local model which we run through our terminal or anything. So as you can see, it's giving types of Drupal. It doesn't understand that. So that's the problem with small models we face today when we run it locally. Second, the second problem which are with the large models. So whenever you use a OpenAI API key or an Anthropic API key for building a RAG application, it is costly. Like when for every response generated, for every prompt triggered, we get the cost increases by for every call. So that's the problem with large models. Even though they understand what's the user preferences or what the query intends to do, that's the problem with large model. And third is like third and main point of my RAG application was I'm working in QED and I'm working on product called Elris. So I was just building a POC for it where a user gives a feedback and RAG adapts, but RAG adapt. But if I see in today, like there is no such system which uh, like the RAG adapts according in like if you consider the RAG right now, whenever user asks a query, it does the same thing every time. It will generate, it will retrieve few chunks and generate a response, and we will get the same set of response for multiple times, and it never consider user preference on a query. So that's the problem we face, like that the current track are very static. They do not adapt with user. So these are the problem we face, and for that we need a adaptive rack. So in I will explain this with a demo, and I will also show how I am training the model with reinforcement learning as well. So I will talk about this in further slide. So this is my journey. So I have built a solution on adaptive RAG by using in these 4 steps. First step is building knowledge. So building knowledge means basically I'm indexing any text file into our vector database. Second is analyzing query. So in my title there was a term called as query clustering, which is basically analyzing questions. So whenever user asks a question, it always has an intent, like it wants to learn, it wants an examples with it wants to compare two different things, it wants just basically a definition in a concise form. So I have written a prompt which again JEMA model will decide that what the user wants, what's the user intent, and I am clustering all those query into a single cluster. Like I will show that in demo. And second is a neural network. So whenever user asks a query, we will take feedback from user with thumbs up and thumbs down, where user can tell if it prefers this response or not, and from that we will train our model. And second is then we will retrieve like for different response types. So I have defined 5 different response types, such as concise, which means it will bring definition in 2 or 3 sentences, as you saw in small model, which is not possible if you use it right now. And second is example driven. Third is analytical. So there are different types of response model, which this response format which I am routing towards. And fourth is the feedback driven. Like it will grow as the user preference grow. Like the neural network will not work properly in the beginning, but as the feedback comes in and the neural network gets built up, it will start giving proper responses, and its accuracy will start increasing. So we'll just show you my demo. So here I will upload a document. I'm going to upload a text file which will get indexed into a database. Right now I'm using ChromaDB as my vector database. Here I will index this text file into my ChromaDB vector database. As you can see, 80 chunks are created, and I have written a testing script. So OpenAI will generate few queries, and it will also tell what's the intent behind that query is, and it will also give feedback to my model for understanding. So for demo, I will just run 10 queries for now. So as you can see, our learning starts. So here is our first query where it asks what blue score did the model achieve on WMP 2014 English to German translation, and it will check the model's response and it will give feedback on its own just to avoid my work. Self-training AI, it is in real time, it is generating queries and also checking response and giving feedback itself. Like I have written a OpenAI script using OpenAI key. As you can see, it is classified into a cluster which is factual, surface, and specific. So factual means what's the intent behind this query. Like if you check this query, it wants factual knowledge. The second, so see here it also give a feedback of negative that we expected a concise response, but our model give an example driven response. So it will train the model based on this, like it will give thumbs up and thumbs down based on each response. Now the second query, its intent is procedure, and as you can see it got classified into a cluster which is as procedure, comprehensive, specific. So different queries will get classified into these different clusters, and then we can train on our reinforcement learning. As I'm running my model locally, so it's bit slow, like the response is bit slow. Yeah, OpenAI generated this question, then it expects this question's answer in concise form, but our model gave its responses example driven. So that's why it gave a feedback of negative to our model. Because for factual, like whenever we ask questions like factual or any definition, we see in second query also it gave a negative because still it gave an analytical, but we expected a structured response for this query. So based on in this case, OpenAI is acting as a user. I have only defined a response format, which is concise. As you can see, concise, analytical, structure. These are predefined. The clusters our JMA generates on the go. So as you can see here, we expected an analytical response and it gave an analytical response. So we send a feedback of positive in this case. So in fourth question as well, give a, so if you here you can see difference, like in case of so I have, if it gives a perfect response, if analytical response, we give a reward of plus 1 point. If it gives a response which is quite similar to analytical, such as structure or anything, we gave it a partial reward which is plus zero point 0.5 points. And if it's negative, we gave a negative response of 0.3. And I actually also tried giving -1, but it was causing a big range and model was not learning properly in that case. So all the queries are getting classified into different clusters, which is the query clustering part. And now after 6 queries, the neural network has been starting to train. So I am training this neural network in batches. So after n number of batches, neural network's weight gets updated and it stays with the current user. So in this project, I have also implemented exploration and exploitation as well. So for each of this cluster, we will decide a best strategy for as a response. Like if it's a concise, if definition surface specific, we expect a concise. So concise will be considered as the best response for that cluster. But as a best response for that cluster, but sometimes user may tend to change its preference. Like sometimes I want like from concise he may move to detail. So in that case we will not fix this response to that cluster forever. Like 80% of time we will give response in concise format, while other 20% time he will try different strategies as well, just to understand if user preference has changed or not over time. So the 10 queries we run, so randomly it generated 5 correct queries and 5 incorrect, which the OpenAI only gave feedbacks from thumbs up and thumbs down. And here we can see the learning curve as well. So here the success rate is 50% because it's a very small data with only 10 queries. I have actually, I will just show you. I have actually trained this model on a larger number of queries where it gives proper output. So I have trained this data over a larger data set where I have actually pre-trained it over 500 queries and also 50 more queries just for checking its evaluation. So in this case, you can see the success rate of with matching the user preference has gone up from 0 to 90%, and the exploration rate. This is the rate which will at which the model will explore other output responses as well. So I have created this analysis. So in this case, you can see how different clustering has been generated for each cluster. So these are the different clusters which got generated during my training process. And as you can see, for the cluster definition module specific, as it the query count was 6, we have chose the best strategy as concise. For other cluster, we aren't able to choose yet because the query count was low, and that's why we couldn't define just because the model is still exploring what could be the best strategy for that cluster could be. For definition, like the best strategy chosen was concise, and as you can see, different for different cluster, the best strategy. So here is one more comprehensive specific. For that also best strategy was analytical. Yeah, so for each cluster, you can see the for concise user didn't like the concise response for such type of queries. It liked more example driven and detailed, which makes sense for the cluster called expression comprehensive specific. For definition, it gave more preference to structured response more. As you can see in this in definition moderate specific, it gave more preference to concise. So the win rate of concise in this cluster was 100%, while example driven was never chosen. It gave a negative feedback on example driven. So here it gave in detailed response in more concise. And here, so if you remember, like when I run the JEMA model from my local, it gave a very big response. Now you can see the difference between the response format it is giving for each query by learning user preference over time. So this is how we can train our model. But the RAG which I have built was on transformers data. Yeah. So current challenges which I have faced was first main problem which I faced was cold start, because for first 50, 100, 200 queries, it takes time for reinforcement learning to actually show its magic over time. Second was cluster classification. As I am as I am using JEMA only for clustering, it sometimes do not form clusters properly. We can actually use OpenAI. It will be less costlier. And last was limited strategy diversity. Like currently, I'm only using 5 output responses, but we in future we can make it more dynamic by adding more response format and making our neural network more adaptive to this. And these are the futures of we can make it multimodal, then personalized user profiles, which is one of the main use case of this adaptive rack. Because if consider if you have built a rack, and for each user will get different response as per his preference. Like every like Alphonse will get different response, user will get a different response based on their preferences. And thank you, that's it from me.